Good morning, guys. So I just found this in my files and thought here's another reading that we can go through. And it is a chilly day, so I'm happy to stay in bed for a bit longer. So this is called The Yoga of Time Travel. A must-read for science buffs, Edgar Mitchell, Apollo 14. Interesting. We can all time travel, says physicist Fred Alan Wolf. In fact, we may already do so. He cites Hindu yoga systems to show how to defeat time through any spiritual practice such as meditation that dissolves the ego. He shows how quantum physics supports his claim and explains in simple terms such phenomena as black holes, wormholes, and parallel universes. Wolf's fascinating scenarios help us imagine what traveling to the past or the future through mind yoga would be like. Provocatively, he suggests it might even improve the quality of our lives. Time travel could, for instance, clarify our sense of self and purpose, reverse aging, and provide wisdom for the benefit of our entire community. So he was a scientist. You see Deepak Chopra, who I don't like. His quote there. See Stanislav Grof. And here we see John Briggs, his little input there. I don't know if this costs $17.95, but I've somehow got it for free. And so he's written a few other books there by the looks of it. Interesting. He's got some interesting titles there. More praise, I don't really care. In fact, if you need it to be hyped up, it may well, be some mainstream simp reading. Because I already know that spirit travels, vertical on the horizontal cross of matter, and that we travel through and forward in time. I often see visions of my future and things associated with the past of this body's lineage. So this is nothing new to me, but let's get into it anyway. Chapter 1, The Ancient Art of Time Cheating. Chapter 2, a brief overview of sacred time and space. Physical time and space enough. The physics of ordinary time travel, the paradoxes of physical time travel. The physics of extraordinary time travel, time, mind, and probability. The spiritual dimension of time travel, summary and conclusion. Classical and quantum computers. So we've got 200 pages roughly there. Let's have a look. Oh, okay, here we go. Okay. I definitely have memories of the future, so I already know that from my own visions. This also, makes you think about how this is a simulation, if you even can do this, because it means that, it's already written and you're just accessing write only, not just read only. But basically, the future is like read only, like when you're computer programming. Here we go, deja vu. Yeah, science says deja vu, as I mentioned here. Science says it's like an occipital lobe delay of like 0.0000 something like that seconds. So a very quick like delay in synapses or something. And I really don't think that explains deja vu at all. Yeah, to be sure, sometimes we also forget events that have made a great impression in the past. Usually they have been traumatic and we don't want to remember them. Like the dolphin dying in front of me the other day. I'm purposely putting a fake memory there, which is not something I often do at all. I have to forget the little scream, and I couldn't help him, so... But yeah, this is well known anyway, and well studied. Oh, I've got a whistler today too, they just won't stop. It's like when your mind goes up in frequency, they start getting all nervous. Gang stalking never stops. They just keep going. It's so funny. What you whistling about? Nothing. Just connecting to me. It's just a funny thing. It's when you're not nervous. Have you noticed that the psychopaths are the opposite of how you feel? If you're happy, they're sad, and the opposite. When you're not happy, they seem very happy about it. And this whistle's like a "hey, you're being monitored" type of whistle, because I just like posted a video about this place. I'm in this hostel. So on the Hive, via the simulation, it's trying to tell me, hey, we know, but I just don't give a shit. Because I could sleep wherever. So they're saying here, but suppose that we're reasonable scientific with the presence of a past would, in that case, both the future and past would be as real to you as the drugstore on the corner in the North Pole. Even though sitting in your chair reading this book, you aren't either of us. You aren't at either of those places now. You certainly wouldn't remember the North Pole if you hadn't been there yet, would you? But that doesn't mean the North Pole does not exist. By the same token, perhaps the future is just as real, and the only reason we have no memory of it is because we haven't visited it yet. So this is fully supposing that the future is written, which I don't battle against that idea at all. Apparently Herbert George Wells wrote about it in 1895. And Albert Einstein and Hermann Minkowski showed how it was theoretically possible in 1905 and 1908 about time travel. Interesting. So it's going to go into all those grandfather paradoxes and stuff. That's good because I've not really thought about that much. Let's take a look at the experiment in which more than 50 years ago scientists observed objects that lived 9 or 10 times their expected lifespan. Yeah, that's an interesting point at the end of that paragraph. Relative time, distance. So that was the introduction only. Yeah, so I know Kriya Yoga is like really old because there's a family that pushes that as well. And I haven't read the Bhagavad Gita or sutras, the Yoga Sutras yet. But yeah, I've, like many of you, heard all this stuff and looked into it separately. Anyway, I've definitely heard of samsara. Conditioned existence, boundedness, the yoking of spirit to spatial and temporal confinement. To me, samsara is like being lost in a journey or a quest. Kind of like just being lost in this universe or this simulation. Basically, this simulation is samsaric, is what I would say. Which goes with what they're saying anyway. I don't think that the explanation Forrestine gives is better than what I just gave. Because, Tao flow is implicated in what I just said anyway. I think seeing it like I said it is a higher form of seeing it anyway. It's like being lost in the simulation. That's what samsara gnostically rings. I always say that there's a gnostic ring of words. You gotta listen to how it sounds when you say it. It's not etymological or nothing like that. And it's not guessing. I'm feeling it. I'm feeling the word. It's what I call the gnostic ring. Organic portals, they can't do that. They can only trace words etymologically, and phonetic, sound doesn't seem to do much for them. Yeah. Samsara has reincarnation into it, yeah. Here we go. Samsara is also a term for Maya or illusion. Yep. That's what I feel in it. Like a sad Maya is embedded in the word samsara. It's like you're lost in the simulation. Oh, look at that. And it says, so we're participating in the flow of these perpetual cycles rather than escaping from them. There you go. Amazing how like correct and accurate I am just from hearing the word. That's how I see it, that last sentence there on that page. Interesting. I know I haven't read this before. So digging deeper in these ancient texts, we find that they say time and space are products of the mind and do not exist independent of it. And quantum physics tells us the same thing. Paradoxically, we need a theoretical picture created by the mind to understand what it means to reach beyond the mind. We also need a form of practice to make time travel real. Not just a theoretical exercise, requires a way of slipping around the corner, peeking under the screen. The Vedas referred to this behind-the-scenes look at creation as kala vansana, literally mean time cheating. In the early part of the first millennium, Indian philosophers found evidence for the beginning of what we today call the perennial philosophy, and it can be stated in 3 sentences: an infinite unchanging reality exists, hidden behind the illusion of ceaseless change. This infinite unchanging reality lies at the core of every being and is the substratum of the personality. Life has one main purpose: to experience this one reality, to discover God while living on Earth. The soul wears the body as a garment to be discarded when it becomes worn. Thus the soul travels from body to body, casting aside old bodies to take on new ones. Just as death is certain for living, rebirth is certain for the dead. But Krishna reassures Arjuna the soul is eternal, not subject to life and death. And Arjuna will not be able to perceive this essential truth, however, so long as he remains caught up in life's dualities, samsara, the choice of everyday life in which we are embedded. Yeah, that's the proper way to talk about it, for sure. How he's talked about samsara there. So in chapter 9 in quantum physics, they're going to talk about detachment. That's interesting. In the context of quantum mechanics, eh? And this better not just be a whole rendition of fucking sutras and the Gita, an Indian philosophy by some scientist. Sounds like this is the backbone of how this is written. Which I don't like, because you get to use a lot of, like, talking about, oh, well, then Krishna said this and this guy said that. And it's like, fuck off, you know what I mean? You're doing a paraphrase and like a copy and then adding some science to it. I don't like that too much. But I guess you got to write something. I just think he should have put it more in his own words, Mr. Wolf. But hey, as a good scientist, he's really good at copying and pasting and cross-information correlation, which is quite spiritless, right? That's how organic portals are. Need to talk a little bit more from his own experience. I'd like that. And he keeps trying to relate it back to quantum physics without even a example there. Just as quantum physics observation by a single mind changes all of the potential forms of matter into a single form. That's double slit experiment, but we don't even know that that's the truth anyway. It's just an assumption. That's what everybody assumes. It could also be decoherence, powerful decoherence, and some sort of illusion. So you don't hear me, you know how you don't hear me going around saying that all the time? I bet like everybody says that. It's amazing, right? It's that double slit experiment conclusion that everybody goes around harping on about the same thing, but the whole double slit experiment, how the particle, when observed, done this and that. Alright, got Krishna with parallel universes. He, Krishna, is time itself, and with the confession comes a great unveiling. Both the creator and destroyer of worlds, for as we know, time favours nothing in its relentless movement. So once we're in Santa Monica, for the reason the reason he has turned to Krishna in the first place is that he is about to go into battle, blah blah blah. So this is just like so much a rendition of the Gita. It's annoying. I can read the Gita if I, want to understand what Krishna and Arjuna were talking about. Arjuna's problem and all this shit. But I really want to hear what he has to say about this time travel stuff, from his perspective and the scientific perspective. Well, here we go. We've got people stand right next to the window while I'm trying to do this reading for you guys. They can't leave me alone. What Krishna tells Arjuna at the end reveals an important theme for time travels. In brief, to time travel you need to leave some baggage behind. Nothing too big, just your ego is all. An ego I living in the objectifiable world of time and space. This illusion is extremely difficult to break free of, no doubt. But you know what's interesting about this ego thing? Like when I've had these visions, it had nothing to do with my ego at all. Like I would just see, a vision of me flying, hovering over a situation, and then 6 months later that situation would occur. Like I'd be in that girl's house or whatever the situation was. I'm just remembering one that was very obvious when I started realizing this back at Gold Coast, like 8 years ago. I would see like events quite often around 2012. It was more and more vivid, but I still had the perspective of my ego anyway, so that was very interesting. Like I still had the perspective of my body, and my life down here on the ground, so to speak. The ego mind is composed of three parts: the mind, the intelligence, and the ego. So maybe I was just left with the mind and the intelligence looking. When one learns to master the ways of the ego mind, pure soul awareness, or knowledge of the true self. When one learns to master the ways of ego mind, pure soul awareness, or knowledge of the true self becomes possible. Invalid, valid knowledge and parity or invalid knowledge. Where's the third? The third fluctuation is actually related to the second. Consists of words without meaning, like Babylon, Babel. The fourth is the fourth movement might not seem to be an obstacle to achieving time travel, but it is. This is the state of sleep without dreaming. Dreamless sleep appears to be close to the supreme state of egolessness. Nevertheless, it remains an obstacle simply because no devotion or spiritual awareness arises in it, like a blank state. There are three states of being: the dreamless state of non-being, the dream state of delusion, and the wakeful state of intelligent awareness. The dreamless state of non-being. The fifth fluctuation is most likely the hardest. Memories of all perceptions, imaginations, thoughts, objects, senses, interactions. Even if you think you can't remember it, it lurks there in your unconscious, ready to jump out. Define the goal as realizations of true self beyond the fluctuation that keep the illusory self alive and well. In the third chapter of Yoga Sutras, Patanjali describes time travel, knowledge of the past and future, as an ability or power that is possible along the way to this realization. Another professor tells the following mythological story from Vishnu. Fuck's sake. I thought this was all going to be based like this on Indian philosophy, like this, with professors, you know, trying to seem eloquent and worldly. Oh, look at me! I know, I know Indian philosophy, but this is all, it's, to me, too much filler. I want to be getting really down to, like, how to do this, you know what I mean? Not reading all these stories. Not really into books like this. And you see my books are more to the point when you read my ebooks. Couldn't even be bothered reading it. That's how much I don't like that. Objective time, by contrast, is the thing we believe to be measurable by clocks. Obviously, can't remember seeing the parent. Galileo did one morning long ago in Sunday service watching a swinging chandelier. You are actually comparing the number of swings you see with your own subjective internal rhythm. For example, your heart rate or your eye blink rate, or even the rate at which words arise in your mind. How do we know that a pendulum makes a good clock, one that keeps true time, except by comparison? Certainly we do compare a questionable clock with another. Yet even though we may check our clock with a trusted timepiece, we perhaps most often notice that our mechanical clocks are incorrect, though comparison with our inner time sense. The human mind is capable of discerning the differences among a vast array of rhythms. Amazing rapid vibration, the quartz crystalline, watching the early journey around the Earth, around the Sun, blah blah blah. Okay, when we examined 5 fluctuations of the mind in Chapter 1, this time sense may be an illusion causing us to think that something has happened, is happening now, or will happen again. This inner, perhaps illusionary connection given to us by the great God of time turns out to be the first tether that binds us in time and space, subjects us to time. Without this connection, the vibrations of music and sound could not play a vital role in enchanting us. Hey, that's interesting. I put Organic Portals music put you in trances in OP handbook. So nice to see them reiterate the word by using enchanting us. Nor could the sun rising, the movement of tides and changing season. Yeah, blah blah blah. Yes, we've got the linear time perspective, blah blah blah. Fuck's sake, how to all subject sense of time. Yet our inner subjective sense of time is as real as any sense can be. Compare with another person's temporal sense. We have abandoned our inner sense of time, not because of the Gita's teaching, but to replace it with the commonly accepted outer sense we call clock time. Yet linear clock time doesn't really exist out there any more than subjective time does. For without comparing clock time with our inner time, subjective sense of time, we would have no measure of difference between our dreams and fantasies and the reality we presently believe we are living in. Without this inner temporal sense, we would not be able to measure the length of a thumb or the height of a tree. Blah, blah, blah. But the light reaching your eyes consists of many frequencies, and these rapid repetitions in turn provide you with a sense of light. Yes, yes. Chronology in India is unreliable in any linear objective sense, and most events were simply a long time ago. That's like topological distance in Australia, just down the road. Okay, cycles and dream time. Chinese and Indians aren't the only people who look at time differently. In a chapter of my book, The Dreaming Universe, I write about the ways of the Australian Aboriginal peoples. In his book, White Man Got No Dreaming, refers to the dream time or the Hatchiriga. Geez, that's fucking racist, because I'm definitely dreaming and I'm definitely white. First introduced to the West by two Englishmen. Blah, blah, blah. Dream time. You've all heard me use that before. Yeah, I did take that from the Aboriginal word dream time. But I just mean it in the sense of itself. Nothing to do with any other culture like Aboriginals. And I think dream time to Aboriginals refers to back before the historical fall, where man was really embedded in nature. Before the first silo at Jericho, which I always mention, just while we were still, like hunter-gatherer, like embedded in nature. You notice that if you spend the day out in nature, you're connecting in dream time. The dream time itself, yes, is eternal and timeless, and so are the spirits of the people who are linked with it. That's that little poem. Yeah, listen, that's what I think they're seeing there. They're seeing the historical timepiece, which is now ended in 2012, don't forget. So the Aboriginals there, by saying white man, him go different, him get road belong himself, they're seeing just the cycle of history. Which, remember, when we look back, is relative to like things like Babylon and stuff, creating language and stuff like that. Them creating it out of thin air. And, previous etymologies and stuff, yes, I understand that, but I hope you understand what I'm saying. It's like an artificial cycle creation. Anyway, fuck, I have not learned a thing. I even knew the stuff about the muons experiencing time differently at the start. This is why I don't read a whole lot, because It's very interesting in 2012 how much we learned without even needing to read stuff like this, by just having direct dream time connection, for lack of better wording, and in the context of what we're reading. Like I said to myself, actually this is very in context, I said to myself, because it was such a time compression around 2012, that everything we learned then, the people of us who were paying attention at the end, everything was so compressed that the things we learned in 4 years will take them another 40 years to learn. What we learned in 4 years will take them 40 years just in the world. Like slowly the science articles will emerge and the texts will be read and so on. But we had it all compressed somehow in that end few years there, the eschaton, around 2012, and namely before it into it. So basically from like 2010, 2009 and 2008 started really compression. It's basically from 2007 to 2017, but on the way from 2007 to 2012 was the end compression. So those 5 years, those 4 or 5 years is what I'm talking about. That's why when I read stuff like this, it's just like nothing. Like, if I read this back in 2007, this would have all been, ooh, wow, ooh, you know what I mean? But it's been realised in a compressed format in that period. That's why I don't get so excited much anymore. So yeah, I was just speaking on the compression at the end, which, you know, that's not linear. That was circular ninth dimensional time really being compressed. Anyway, this is not my book. Anyway, I'll talk about that all in The Eschaton, a book I'm going to write called The Eschaton. I'll talk about time in there. Anyway, let's return to wise old Augustine. One wonders if he in some way realized the theory of relativity. For he goes on to say, "Yet I say with confidence that I know that if nothing passed away, there would be no past time, and if nothing were still coming, there would be no future time, and if there was nothing at all, there would be no present time." Compare this with 2 modern-day statements on the mystical or mind-like nature of time. People like us who believe in physics know that the distinction between past, present, and future is only a stubborn, persistent illusion. What we mean by right now is a mysterious thing we cannot define now, is an idea or concept of the mind. It is not something that is really definable physically at the moment. The first quote from Albert Einstein and the second from Richard P. Feynman. Both Nobel Prize winning physicists, blah blah blah. Alright, let's have a look what he says here. Physics of it all. Study in schools, blah 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 blah. Radio, yeah, the electromagnetic spectrum. Okay, let's see. The first has to do with how fast light travels. That's particularly relevant. And the second relevant point has to do with the way it travels to our eyes. Yeah, like I always say, you know, when we're looking at an object with our physical eyes, it's lagging light. Right, it has to bounce off the object. And the speed of light changes. It's not a constant. The speed of light does change, and it has been recorded to be changed. Which speaks on the speeding up of time generally, or the speeding up of occurrence, this universe simulation. So that's pretty interesting. I don't know how many of you knew that, but the speed of light's definitely not a constant. It doesn't just stay still. And we've only been recording the speed of light for what, like couple of hundred years, out of billions and billions of years. So how do we know? And if it's changed in just our little blink of an eye, look at it, inspection, then it's definitely not a constant, right? Oh, and now they have to start music because I'm talking. Sir Isaac Newton imagined light in the late 1600s, or does it? Like tiny particles of bullets in a vacuum. That's the way Sir Isaac Newton imagined light. And we discovered it moves more like waves in water than bullets. Oh, okay, anyway. Yes, interesting. But when we're given the opportunity to move quickly enough near light speed, they exhibit the strange property of living longer than they should. So the faster that you travel, you seem to live longer in the space around. This discovery about the minute particle has far-reaching consequences for our understanding of time and even for our understanding of Einstein's special and general theories of relativity. Well, you definitely age less when you're in your mind flying, right, at that faster speed of mentality than rather than being the focus of an event down here in the third dimension. That seems to age you, right? And you can feel that. This discovery, known as time dilation effect, sounds tricky, blah blah blah. The principle of, oh, here we go, let's have a look here. The principle of least action. Let's see what they say here. Handiwork. One such principle, every once in a while, a principle of great depth is revealed. The principle of least action. In essence, it says that things move in whatever way makes the universe more efficient, as if God does not wish to waste resources. Path of least resistance in the jungle of the universe by God. Right. Einstein recognized this efficiency principle and incorporated it into his general theory. Instead of least, the word is extremum, which means the absolute minimum or the absolute maximum value that anything can have, in spite of the complexity of the universe. When things move naturally, no matter how or where they go, they tend to move along extrema. In other words, something about their motion takes on either a maximum or a minimum value. For example, imagine yourself sitting still in a spaceship traveling to Mars. Your path in space is natural or effortless enough, and you're moving at a constant speed on an extremum through space. If the astronaut sitting next to you in the spaceship were to move away from you in another spaceship and then return, and the two of you compared clocks, his clock would show less time had passed than yours would. On the other hand, if you were to compare your clock time with that of another clock that was at rest, compared to you, your time would be less. So the less you're doing something, the more time passes. The general rule indicates that time itself depends on motion, and specifically how that motion takes place. Yeah, that's very interesting. According to both the special and general theory of relativity, the time you spend moving along any naturally occurring trajectory through space turns out to be an extremum when compared to the time observed by another person who also started out when and where you began and ended where and when you ended, but followed a different trajectory. The starting and ending points for two or more such observers are called events. It would seem that since they both started together and ended together, they would both pass the same amount of time, but in relatively appearances are deceiving. Let's have a look here. In figure 3.1 we see two events, A and B, separated in space and time. And two paths or trajectories beginning at event A and ending at event B, even though both started from the same event and end at the same event, the trajectories are very different. A clock that travelled along the curved path would actually record less time passing than a clock that travelled along the straight path, and you wouldn't think that. Let's keep reading. Remember, we're only comparing clocks that move along different trajectories but have the same endpoints. If we compare this time spent on any one of these trajectories with the time indicated by clocks that are not moving, the moving clock will always show less time. Among these moving clocks, one of them will show the most time passed. The trajectory travelled by the clock is called a geodesic in the language of general theory of relativity. In figure 3.1, the straight path is a geodesic, while the curved path is not. The word geodesic actually means the shortest distance between 2 points on our planet. Physicists working with relativity theories borrowed the word to mean the extremum between any two events separated in space and time. Well, that's very interesting that why should the curved line time spent equals 10 minutes, straight line time spent equal 1 hour? It's weird. Let me give you some simple spatial geodesic examples. There's no freaking explanation though, right? It just says, yeah, it's just like that. And, well, I know we just read about the speed of light, but it seemed a bit of a jump, a bit of a gap there. Let me give you some simple spatial geodesic examples. You have heard that a straight line in the shortest distance between any 2 points. This is true on a flat surface. If you draw any other line, such as an arc, between 2 points on a piece of paper, the length of the arc will certainly be longer than the straight line. Yeah, that's what I'm just thinking. Hence, the straight line is the extremum, in this case a minimum length extremum. However, a straight line is not an extremum on all surfaces. In fact, extrema depend on the shapes or curvature of the surface in which possible trajectories are drawn. Take a sphere in hand if you have one. If you don't, an apple or orange will do. You can draw a straight line or on a sphere, can you? Your line must follow a curve. The shortest length curve you can draw between any 2 points in the sphere forms a segment of a great circle, which means any circle on the sphere with maximum circumference possible. Segments of such arcs form minimum length extrema. Indeed, in this age of transcontinental flights, especially transoceanic flights, airplanes follow great circle routes to go economically from one place to another. It's a bit surprising to find we must fly northward and then southward to reach London from Los Angeles. We are used to thinking of Earth as a flat surface, a habit that comes from looking at planar maps wherein Delhi is west of San Francisco, while Moscow, for example, is considered to be to the east. Europeans refer to countries like India and China as the East or the Orient because it is traditional to think from a flat Earth. European point of view. Oh man. Hence a straight line between Los Angeles and London drawn on a flat map will not even be close to the actual shortest length between two cities. A great circle route that heads northward, nearly reaching the pole, and then southward across the Scottish Highlands into London will be the shortest route. Great circles are examples of spatial extrema, usually the shortest distance between points. However, when we begin to consider time along with space, as we do in general relativity, the extrema change, it's quite a surprise to find that extrema of trajectories that consider both space and time are those that take the longest time periods when compared with other trajectories between the same endpoints. Let me take a little more time to explain this. Please. It's quite a surprise to find that extrema of trajectories that consider both space and time are those that take the longest time periods. Anyway, modern physics has shown us that time and space are not separated. Perception is illusion. Physics goes times space-time. We owe this new perception to things to Albert Einstein. These equations traced out how it was that two observers moving relatively to each other in a smooth and unaccelerated manner could come to different conclusions about when and where of an event they both observed. In case you are wondering what moving relatively to each other means, think of two rocket ships each moving at constant but different speeds. Yeah, righto. It doesn't matter in which direction they are going relative to each other. All that matters is that when each one sees the other will appear to be moving further away or closer. The problem was how to compare measurements when two observers were far apart. Different speed. Since Young's experiment had shown that light behaves like a wave, the question was, in what medium was the light wave waving? And then they used the word ether all the time. even though everyone thought that space was empty, through it light must travel from the sun to Earth, thus light must be waving through something as it makes the trip. Yeah, and they called it the ether, which made us be the Planck length. Like a great ocean in space, the ether was thought to fill all of space and everything that moved. And, it's not been proven. Since the Earth moved in large, this should result in... And I've seen articles written on, does the ether need to exist? Apparently not. So it's all still controversial to this day. This should result in the presence of an ether wind affecting light speed on Earth, just as wind affects the motion of any object, even though light moved extremely high speeds. And the Earth moved much slower than that around the Sun. Okay. Morley attempted to measure the difference in the speed of light due to the Earth's motion relative to that ether. To their surprise, they found no difference. Einstein showed that even though it made no common sense that two observers moving at different speeds would see light coming from a common source, as travelling at the same speed, nevertheless, it had to be true. Speed would see light coming from a common source. And to accept this truth about light's speed meant giving up our ordinary notions about space and time. Scientists had as much trouble grasping this as did the general public. For example, consider our sun around 8 light minutes away, shining light in its usual manner. So suppose that another observer who is moving very quickly relative to us, perhaps at nearly light speed, is also observing our star. Suppose the sun suddenly gets a bit berserk and emits a gas cloud that temporarily occludes the light, a so-called sunspot. Then a few minutes later the sun calms down and the spot disappears. For us, these events would appear to occur at nearly the same place in space, perhaps slightly shifted due to the Earth's rotation, and within a few minutes of each other, but the other observer would have an entirely different experience. She might see two events separated by years of time and millions of miles in distance. What? Between 1905 and 1908, all of the mind-boggling examples arising remain just that. No one could really understand them rationally or even intuitively, in spite of mathematical success and logical behind that math. Einstein had certainly shown that we couldn't think of space and time as we were accustomed. But the notion of space-time as a single entity hadn't really occurred to him. All this began to change in 1908. That time and space are not independent of one another and can be difficult to grasp. Space seems to be infinitely out there, filling a huge blackness, an enormous emptiness, great void, while time seems so fleetingly in here, personal, subjective, and hardly ever brought to our attention unless we're watching a clock or timing events. Apparently, when they were on Mars, allegedly it took 10 minutes to reach the tiny Mars rover, their signal. These commands were carried by radio waves, just another form of light energy, and hence were limited in their ability to alter the rover's movements by how fast the signals could travel. You may have had the opportunity, as I did, to view the live television coverage of the rover's first steps. I remember how eerie it felt, watching the rover and realizing that the picture I was seeing on the screen had to travel for more than 10 minutes at the speed of light to reach me. It drove home the fact that space and time are absolutely connected, a single thing we can call space-time. He didn't even explain more of what he said he was going to explain from that above diagram. As physicists accepted that space and time are inseparable and began applying the general and special relativities, they decided to call the travelling clock's time proper time. They began to wonder what to call the time experienced by a clock travelling along a space-time trajectory when compared with the time shown by other clocks that are not travelling on the trajectory. They decided to call the travelling clock's time proper time. No, proper time isn't the polite hour you spend visiting your rich great-aunt Mary in her mansion at high tea. Rather, it refers to the time you spend moving along any trajectory in space-time from a beginning event to an ending event. Other travellers could have followed different space-time trajectories between the same two events, and their clocks would show different proper times. Different space-time trajectories. One of these trajectories would be geodesic, connecting the events. It would show the maximum amount of time possible between the two events. However, I remind the reader that what is a maximum and what is not depends on who is doing the measuring. Non-moving clocks will always show more time lapse than moving clocks. Isn't that interesting? Fuck, man. Well, moving along a geodesic means moving along the most natural or effortless pathway and the longest time possible, but always a shorter time than other non-moving clocks between two events. However, as we have seen, this is true only on a flat plane. On the surface of a sphere, the geodesic turns out to be a curved line through three-dimensional space. Let me summarize. Proper time is a measure of the time spent along a space-time trajectory as measured by a clock moving along the trajectory. Proper time is always shorter than non-proper time. In other words, moving clocks go slowly when compared with clocks at rest. These other clocks, usually at a distance, could measure the time spent by an object moving along a trajectory, but they would not be the proper time of the object. Space-time geodesics mark the greatest proper time between events. Space-time geodesics mark the greatest proper time between events when compared with any other trajectories having the same endpoints. Space-time geodesics mark the greatest proper time between events when compared with any other trajectories having the same endpoints. As an example, suppose you and your brother are sitting together on a living room couch. You just sit there without moving from 1 p.m. Tuesday to 1 p.m. Wednesday. The epitome of a couch potato. However, even though you don't move an inch in space, you're moving along a geodesic in space-time, since the Earth is turning and also progressing along its orbit around the Sun in a natural way. The amount of time passed that you observe on your watch is a proper time of 24 hours. Meanwhile, your brother gets up from the couch at 1 p.m. Tuesday, rushes out the door, climbs aboard a jet airplane. He flies at 600 miles per hour for 11 hours, then gets on the next plane back, returning to your city in about 11 hours. Give or take traffic conditions, he makes it back on the couch at 1 p.m. Wednesday, as witnessed by you. After he arrives back home, you sit down together and compare watches. Even though he sped through the universe for a while, as far as he was concerned, he was at rest in his airplane, with his watch showing his proper time. Since he had artificially accelerate when taking off, landing, driving to the airport and so on, he figures his trajectory was not a geodesic when compared to yours. Was he correct? You compare your watch to his, assuming you both have very high resolution atomic timepieces, accurate to a few nanoseconds. What you will find is that his watch shows less time passed than yours. Not much, just about 35 nanoseconds less. If he had travelled at, say, satellite speed around 25,000 miles per hour, that time dilation would increase to around 60 microseconds, or 60,000 nanoseconds. Alright. If he had been able to move at light speed, that dilation would come to 24 hours precisely, meaning that he would not age 1 nanosecond during the 24-hour period you sat lethargically on the couch, aging a full day. That's right, moving at light speed, even though the time spent is all that can be spent, turns out to be no time at all. So your brother was correct that his trajectory was not a geodesic. Both the traveller and non-traveller experience proper but different times between the same events. However, since the traveller moved along from one point to another and then returned, his path through space-time was not a geodesic, hence he experienced less time than the non-traveller. I'm just going to end the recording here for now. Chapter 4.